Welcome to the culmination of our beginner series. This is the point where we put everything we have learned together and create our first game. Now I first want to impart you with some of my thoughts on the subject of creating games. It is very easy to want to create something very ambitious, which might grow out of control and eventually never be finished. I think it is very important to actually create goals that are both feasible and realistic. So that is sort of what we will be trying to accomplish with this last phase of your start into learning game development in Unreal Engine. We will create a small game, but we will start around its core concept, and then we expand upon that with layers and new features as we go along. So at any point you can stop and say you're finished and you have a playable game. Or you can keep adding new layers and system until you're happy with the end product. Anyway, I hope you keep these thoughts in mind as you keep learning more Unreal or game development in general, and let it guide you when you create games in the future. That's enough of that, let us get started. So here we have what it will look like in the end. You can see some elements like time remaining in the top there, and you can see some UI elements saying that a certain amount of resources on hand. In addition to that, we also have this sort of warehouse area built, which our level will take place in. In addition to that, you also have the functionality of if the time runs out, you'll have this game over retry screen, so you can either quit the game or retry and it will start over. And if you go around here in this level, you can see that we have, among other things, this engine that's spinning around over there. It's representing a drop-off area. So what we can do is we can pick up engines that are manufactured from that machine over there, and we can drop it off in these areas and we get bonus times. And we also have some fire extinguishers, so we can pick those up and bring those to this area, which is for fire extinguishers. And yeah, this is basically the functionality that we will be creating today. You can also see that there are resources inside of the machine that it's using to create the items that it's sending out. So this is what we will be doing in this tutorial series. Today we will be using Unreal Engine 4.26, and we're using a first-person template as our base. It is a completely fresh project and we'll create everything from scratch. Everything we will make in this game is going to be on an iterative process. We're going to be adding things part by part, but we'll start around our core concept, create that, make sure that we have that in place, and then expand upon it with each new layer adding some complexity or interesting feature, allowing it to be a more interesting game to play in the end. So let us talk about the game we're gonna create. We're gonna create a game that in its most basic form is just about having objects in the game that we can pick up, then taking those objects to a different place and then just handing them off. That's it. That's gonna be like the core concept of the game. Then we'll add upon that to make it more interesting as we go along. But we'll start with that and see where we are. To begin with, let's do some cleaning up. First we want to start with our first person character. You can either click it in the viewport or you can find it in the world outliner, and then we'll open up its blueprint. What we want to do is we want to have our gun act as a sort of levitation gun. So that will be our justification to be able to lift these items up and transport them around. So we will be keeping some of that, but we will be going into the event graph and changing how the game currently works with the gun, which is when you have the input action fire or from an input touch, it will be playing a montage, spawning a projectile, firing it away, and playing a sound at a location. The only thing we're interested in keeping potentially is the montage play of the animation, actually making the jerking reaction of a shot being made. We are not interested in the actual projectile or the sound, and we might actually throw out the montage in the end as well. We'll see what it looks like when we're getting there. So for now we'll mark everything that is below the montage play. That in the end here actually ends up with the orange connector. We'll delete that. We will mark everything that's used for motion controllers in the bottom here, and we'll delete that. We will mark the projectile spawn, the sound and everything like that, and delete that. So now we have cleaned it up a little bit for now. We will compile and save. We might come back and clean up some more stuff later, but for now this is okay. Let us go back to our map and click on content. We want to create a folder, call it blueprints. This is where we will be keeping our classes. We right click and we add a new blueprint class of the type actor. Call it BP underscore pickup. So this will be the class that represents what we will pick up in the world. Let's open up that blueprint. Inside this blueprint, we first want to make a visual representation of it, so we can actually see it in the world. So we will be adding a component of static mesh type. We will call this pickup mesh. Now in this particular instance, we will be using a box as our mesh to show it in the world, but this class will act as our parent, which we will make other classes from later, so they might not be looking like boxes, so we want to have a name for this mesh that would properly describe all of them. That is why we use pickup mesh as our descriptor. From here now, we go to the static mesh and we choose the 1M cube here. We move it up a little bit so it's flush with the grid. We compile, save, we go back into the map. Okay, so now we have created our first object, this pickup object. Let's move it out into the world so I can demonstrate something. We'll put it on the edge of this box over here, so it's like that. And now, what we want to have is an object that sort of feels alive in the world. We want it to be able to move around and react to its environment. So let's see what it looks like currently when we play. Start play, we move and look. Well, this object is standing on the edge here. That doesn't look correct. So what can we do about this? Well, we want to simulate physics is the gist of it. So if we go back to our pickup class, on the mesh, in the details on the right, there's a physics section which allows us to simulate physics. If you check that box, compile, save, go back to the map, press play again and look at the box, you can see that it falls over. This looks pretty nice and it fulfills the sort of feeling that we want to have with our objects. So that's a good start. The next part we want to do is we want to be able to pick this up. So how do we do that? Well, if we go to our first person character, we go to the viewport. We want to have our gun act as the object that allows us to pick other objects up, our levitation gun basically. So to make that possible, we want to have sort of an anchor that we can put in front of our character to say, this is the place where we want to have our objects be when we're moving around in the world. To do this, we're going to add a component. So we click up, add component. If we go down to the bottom, we have something called a scene component. Click on that. Now, the scene component, we should name something like pickup anchor, so that we know what it does. And we want to place the scene component, our pickup anchor, somewhere in front of the character. Maybe something like that looks okay. We'll compile, save, move back out into the map. The next step now is we have an object out in the world. We have a place where we want to place it when we pick it up, but now we need to be able to actually pick it up. So we will add some logic to do that. We go to the first person character, go to the event graph, and we do something similar to what we have done in earlier tutorials. We will start off by right-clicking and typing keyboard E should bring up the E key. So this will represent our action of trying to pick something up for now. We will be enhancing this later on, but for prototyping right now this will be okay. So we have spoken about different ways of getting references to different actors in previous tutorials. For now, what seems to be a logical way of handling this would be something like a line trace, tracing out from your character. So let's make a line trace. Right click, line trace by channel. We will take our connector from being pressed in to execute it. Now we need our start point. Like we spoke about earlier, we had a capsule component that we could use. We can drag that out. Then we have a reference of where it is in the world by getting a location. So then you have a world location and you can hook that into your start. And we can also from the capsule component get a forward vector. And this one we want to multiply with a float. The reason for this being that, like we discussed in earlier tutorials, we want to have a certain distance in the world where we want to scan our line trace, and if we find anything interesting from that line trace, then we want to act upon it. So we can right click on this float and then promote it to a variable. We can rename this variable by F2 and we can call this trace distance. So now we have a distance in the world here, but the default for this when we compile and save is going to be 0. So that's not good enough. So we will add something like 300 for now. So this is a variable, so it's easy to change later on if you feel it's too short or too long or anything like that. In addition to having the direction and the length that it's going to be going, we want to have add a vector of the world location where we are to say it should be counting from that position in the world. So we add a vector. Maybe a plus sign will give us, there we go, vector plus vector. And then we add those two vectors together and we use that as our endpoint. So now we have a start and an end for our line trace to use. Everything else here seems okay for now, so we will compile and save. We will then find our out hit here and we will split that because we want to get the actor, the out hit actor. We want to cast it to pickup, BP pickup. If it succeeds, then we want to pick this object up. So the first thing we want to do is make sure that it is actually in the position that we want to have it. So we have our pickup anchor, we can drag that in, we can get its location, and this is the location we want to set for this pickup that we just found. Set location, set actor location, and then we plug in our new location and then we compile and save. So now let's test out and see what happens with our current logic. Go back and play. Look to the left, we see our cube falling over. We walk up to it. Nothing seems to happen. Why, you might wonder. So let's go through the process of troubleshooting, because this is something that's very important. You will a lot of the time be spending a lot of effort and time finding out why is something broken. So let's go through some of the basic ways of how you can go about trying to identify what is the problem behind what you're doing. So we seem to be having done everything right, but nothing is happening. So we can go to our first person character and we can go and check, well, is this actually executing at all? Well, let's see. We'll type up print string. We'll drag off a node here. So print string is very useful for debugging when it comes to things like this. So we can say like actor location set. Compile, save. We go back in, we play. Go in. Well, we see that it says actor location set, but still nothing is happening. Okay. So something, it seems to be interacting with the actor. We are setting the location, but nothing seems to be happening. To understand this, you need to understand a little bit of what we did earlier, which is that the pickup here is our actor, and that means the whole blueprint. What we have done is we have added a pickup mesh that is subservient to the blueprint, but this one has simulate physics on it, which means that this one can go about doing anything that it wants. To make this very clear, let's add another component of static mesh type. We can just call it test for now. We will attach it to the default node so that it has the same hierarchy as the pickup mesh. We can choose a static mesh that's different from the other one, so we'll just pick sphere just because it's different. We will raise it up a little bit so that we see that we can see both of them at the same time. And we will turn off collision by saying, well, block all dynamic, we change to no collision. So this means we have one static mesh that doesn't have collision and one static mesh that has collision and simulate physics, which is the cube. What does this look like in the world? Well, let's play and see. So now it should be fairly clear to you what is happening, I hope. If it isn't, let me explain. We placed an object up there of the type pickup, where the sphere now is. The sphere doesn't move, it doesn't react to physics, so it's just going to be there in relation to its actor. So that is actually where the class actor is right now. So the object is over there, but the box itself fell down. Okay, what does this tell us? Well, if we go to the BP pickup, no, the first person character, sorry, we are saying the pickup anchor that we made for the first person character, we get its location and we set that on the actor location of the pickup. That means that this pickup that's up here is the one we're actually moving. If we play again and go in and see, you can see there's the sphere and down there's the cube, but if we go here and interact with this one, you can see that the sphere appeared where our pickup anchor is. So this is the issue. These two items are now not in sync because we are moving the actor, but the mesh or the box itself can act independently from the location of the original actor because it is simulating physics. So we can approach this problem slightly differently. We can go to our set actor here, and instead of doing that we can drag out from the pickup. We can get our pickup mesh. So now we have the reference to the actual mesh. So we could do that and actually change the location of this target instead. So if we do that, we set location, set world location, drag the execution node to this instead, and then the position in there as well. We'll move this out of the way for now. Compile, save, and go back in. Let's see what happens now. So now we see every time we're interacting, we're moving the box to where our pickup anchor is. So that is nice. However, the object itself is still staying over there. For our purposes, this just might be fine, because the object itself in our world is the box, even though the object derived from the class has a different position. That's not really relevant for us in this particular instance, because we want to interact with the box itself. So we can go back to the pickup. We can leave it in for now, the little sphere, so we actually have it as a debugger, and we'll clean it up a little bit later. So we've come to the conclusion that what we want to transform is actually the pickup mesh instead. The problem we're running into now is that when we have this object picked up, or rather we try to pick it up, it falls down to the ground immediately. We need to keep it in place where we have our anchor while we're moving about. One way to go about this is to attach this component. The pickup mesh itself is a component of the actor. Our pickup anchor is a component of this actor. So what we can do is we can drag from the pickup mesh, we can say attach to, and we get some attach actor to component and attach component to component. Since we want to attach the component because we noticed earlier that actor won't do us any good because it will desync from the location of the actor, we will instead choose actor to component. So we'll pick this node and we will attach it after we have set the world location. Actually, we can remove the world location for now. I think this will be fine. So we'll disconnect that for now also. So we actually, let's remove this completely so we don't have anything confusing here. So what we're saying is we want to attach the pickup mesh to the pickup anchor. And then we have a few selections when it comes to its translation, rotation and scale. And relative is not gonna be great because it's basically gonna be problematic. It's a little bit hairy to describe, but if we take the world locations for all of these, then they will be keeping them intact between the two different relative positions. Let's see what this looks like when we try it out. We walk up to the box, we press, well, it isn't attached to the component, you might think. Well, this is all perfectly valid because what's happening is each time we press here, we try to attach it to our component. And that's all good and fine. However, it's still acting under laws of physics here. You can see that it bounces into objects, things like that. And the reason for this is that it's still simulating, so it's sort of getting conflicting, not entirely conflicting, but the instructions of being attached and also simulating is causing some discrepancies for us. One solution for this is that if we go back to the first person character, is that after we have, or by the same time, when we're deciding to attach something, we're also stopping it to simulate. I changed my mind. We want to do this. Let's do this. We set world location for this one. The reason for this is because the attachment is happening. We're saying that when we click on this object with the line trace, we're saying that the position it currently has now, we want to attach it to the pickup anchor, we don't actually say put it at that location, which is actually going to be sort of key for us. So we want to set the location. We then want to attach it to the component so that it keeps there and don't keep falling down. And an additional thing that we need to do to make that work is, let us clean up this mess of connectors a little bit quickly, and I'll continue. Okay, a little bit better. For those with OCD, they probably want me to raise this one a little bit. Okay, so we set the world location for the object, so it's actually at our anchor point. Then we say keep it in world location, rotation and scale in relation to the pickup actor, but we're still simulating physics. If we were to turn off the simulating of the physics, then it would not fall down after we have picked it up. Let's see, we reroute this one down here. That's a bit better. Okay, so now with these 3 steps, we should realistically be having a better interaction with the box. Let's try it out. Okay, we move around. You can see that while I'm turning, the box turns around with me and everything seems perfectly okay in that regard, right? Not entirely true. I don't know if it was visible. Let's try that again. We walk up to the object, we pick it up, I walk backwards, I walk forwards. Now you can see I'm trying to walk forwards, but I'm being pushed backwards. The reason for this is that the box is still generating collisions and it's trying to push the collision of the box and the collision of the first person character capsule away from each other so they don't collide, because the pickup anchor is so close to the capsule that the box is probably intersecting it slightly, making them want to push away. So, like many problems, there are many ways to solve it. One approach might be, well, you might be thinking, as soon as you pick up the object, you might not want to be having it make collisions anymore. And that is one way to possibly work around this. So let's try that out. We'll go back to our event graph and we will continue here from, this is the node that comes from the pickup mesh. So we can just drag from this reroute node and we can say set collision. Set collision enabled. Drag in a connector there. And then we go and say no collision. Compile, save. Let's try it out. Okay, now I'm moving backwards and forwards properly. Everything looks fine in that front. And I can move around and everything like that, so that's good. However, you might notice that it's taking up a lot of screen real estate to have an object in front of you like this and move around. So let's look at fixing that now. Again, a new problem, lots of different ways to fix it. One solution would be to, for example, have our pickup anchor moved further away. That way we would be having it take up less space because of the properties of perspective. A different way might be to possibly change the scale of the object once we have it picked up and then return it to its normal state when we put it down again. Let's try with moving it a bit forward and see how that looks for us. So we'll move it a little bit further. Compile, save, and we'll try it again. that looks more manageable. It's still obscuring a bit of the screen, but I'm assuming that's to be expected when you're moving a large object around, so I think we can live with that particular solution. Having it, for example, scaled down is something that would work as well. The problem would be that you would have to make sure that you scale it up and down as you pick it up and leave it and things like that. It leaves some variables open for errors further down the road if you don't keep track of both of them at all times. So let's start looking at the possibility or ability of letting go of an object. If we go back to first person character, the event graph, we now have a few things here that are happening when we have completed a line trace and we're picking everything up like that. So this might be a good time to actually encapsulate this logic into some code, some functions actually. So we'll do that in a moment. Before that though, we first want to start creating our second class, which will be sort of our drop-off area. And we create a new blueprint class of the type actor. Call it bp underscore drop off area. Save that one. We go into our blueprint class and for our pickup, no, for our first person character, sorry. Then we want to make this function. If we mark everything, right click, collapse into function. Let's see how well it does it. Seems okay. So now that logic was sent into a function and it realized that it needs to send this pickup in as a parameter in. So we will start off with renaming the function to something more useful, like pick up objects. And the parameter for it we will rename to pick up objects. No, that's not very descriptive since the name of the function. Let's call it object to pick up. Compile, save. We can double click into the function. We can clean it up a little bit. We can check how it has fared. It's calling the set for location. It's using the pickup actor. Everything seems fine. Good behavior is always to add a return node in the end. You don't always need one, but it's good to see. It makes it clear to see where the execution ends and during which circumstances, because you can have multiple return nodes for different game flows. Since we now have this here, we want to right click on pickup object function and duplicate it and call this one drop down object, because we're gonna do something very similar as when we're picking up, but we're gonna do some of the things in reverse. For example, we do not need to set a world location anymore because we're just leaving it where it is now. So we'll remove that, which means we don't need this get world location. We don't want to attach it to a component anymore. We do not want to simulate physics. Actually, we do want to start simulating physics again, and we do want to resume having collisions again. So let's make these changes one by one then. We have our pickup mesh. In contrast to attaching, we want to detach from component. And we will put everything to keep world so it doesn't teleport anywhere. After having done that part, we can remove the attached component, now that we know that we have done the opposite of that. We need to start simulating physics now, which is easy because we just need to set this flag again. We will move these a little bit so they're looking better. We do not need to have this node here, and we do not need the anchor for anything. Collision enabled is going to be resumed. Query and physics. We move the return node a little bit closer. That should be fine. So, how do we know when to drop down the object now then? Well, we go here to our instance of interaction. What we want to do now instead is we want to add a variable saying is holding object. We will make this a boolean, like so. And we go into pick up object. This is the point where we have decided that we have picked up an object. So at this point we want to set this variable to true. Like so. By going to the, oh, we renamed this function wrong. It should be drop down, not draw down. We go to the drop down object, and as we do things in reverse here, we want to say we're no longer holding an object when we have dropped it down. How is this useful to us? Well, a few things. The first thing we can do is clean this up a little bit by saying that we want to collapse this into a function as well. So we'll call this function trace for object. Let's call it, let's rename these ones. Trace for pickup. Let's rename dropdown object to dropdown. Actually, that doesn't make it a whole lot better. Pickup would, yeah, we'll stick with this for now. Anyway, so we have a trace for pickup, which goes out here and does this. But what we want to do is now react upon if we're holding an object. So if we're holding an object, we branch. In the case that we are not holding an object currently, we want to try and trace for an object, and then if we find an object we want to cast it to a pickup, and if it is a pickup then we want to pick up that object. So if we are currently holding an object, then we just want to drop that object. Like so. Now you can see that it has an object to pick up here. Doesn't make a whole lot of sense for this right now, so we'll go to the drop down object. Now this particular function needs to be altered a little bit. First of all, the naming is incorrect here because the object to pick up is not correct. We need to name it object to drop down. That's the first part. However, this function still needs this object reference to be able to say it should detach and to set simulate physics and everything like that. So we need to send the object reference to this function. If we go back to the event graph, we don't actually have that reference right here. We got one from the trace earlier, but we won't have one in this particular instance over here. So what we need to do is we need to add another variable. Held object. We will make this of BP pickup type. Object reference. Compile and save. So what we will do is we will send in this as our reference to drop in the world. But this particular reference is never set. And the one time when we should set this would be when we're picking something up. So we go into the pickup function and we set this held object in here. So the held object that we're setting is this reference that we're getting in here. So we'll try and make this clean as we can by using some reroute nodes. Actually, let's move this. That will make it cleaner for us. So we'll set it here instead. There we go. So in the beginning of the pickup object function, we will set which object we're actually currently holding. So that will be telling our blueprint that this is what we now have, so that when we later try to drop down something, it drops down that object. But is this gonna be enough? Well, I mean, let's try. We go to play, walk up to the box, try to pick it up, it's following us around, we try to drop it down, it drops down. So the test would be now if we can actually pick it up again. And that seems to work perfectly fine. So for our intents and purposes, this seems like it is a solution that will hold. So let's get back to our drop-off area then. Our drop-off area we didn't actually do that much in, but if we add a component here, let's add a static mesh. This is to give us the visual representation of the drop-off area, so we'll call it drop-off area mesh. And we can set it to be a cube. And we can scale this one a little bit, so we flatten it a little bit, maybe something like that is fine. Actually, let's decrease the sensitivity of the scaling so we get something freeform. Something like that, okay? So this is now representing the area where we can drop something off. The thing we need to have here now is an actual volume to react with this. So we will add a collision of box type, and we will say drop off volume, and we will scale it so it's approximately the same size when it comes to the square, because the square is what the player will actually see in the world as the drop-off area, but the volume is what will actually be registering if something is in it. So we compile and save. So there are a few different ways that we can do this. If we imagine, for example, the player would walk into the area and then press his drop down functions, we could try and have a listener to react to a event dispatcher that would run when that happens. But then you will have situations where, what if a player stands high above the volume when he drops the cube? Then the cube would fall into the volume, and then the player has already dropped the box, which means that the volume would start to listen for an event that will never come and such like that. So something we can do to alleviate both of these issues is to have the volume check for a multitude of things, or to simplify it. We could, for instance, have that the volume has an internal timer on it. Let's say maybe 10 times per second, or maybe 2 times per second, or maybe 1 time per second. It would check, are there any pick-upable objects inside of me that currently do not belong or being held by a player. That is one way to do it, but then we need to keep track of an object needs to have the property of being picked up. So let's try that. We'll go to our BP pickup and we will add a variable saying currently held by, and we will call this variable type first person character reference. There we go. And to be able to set this function, we need to have a event. So we'll add a custom event. We'll call it set person holding object. And we will add an input to this. Person holding. And we'll change the type to first person character. Now whenever this event is called, it will set its value to be whatever is being sent in here. Okay, this way we have established that this object has ownership by someone. Now we need to actually set that ownership. So we do that in the first person character. When we pick up an object, that is when we establish that we own it. So what we should do, first thing we should do is we go to our object reference here and we say, what did I name it? Person, set person holding object. And then we call that, and then we execute in here. Then we tidy up a little bit. Let's do something like that. Okay, but now we need to establish who is the person holding it. Well, it's this blueprint that is calling here, so we'll just type in self and send in ourselves as a reference to this event. So that should do it for whenever we're picking something up. What about when we're putting it down? Well, we do the same but opposite. So we get our object reference, person holding object, and we connect that, then we connect here. But this time we're saying that nobody's actually holding the object, so we leave this one empty, which means that it will set it to nothing when it gets the call in the BP pickup. Okay, that seems fine. Let's see if this actually works then. So if we have our drop-off area blueprint, we will click on our drop-off volume. We will go to no, that's not going to be good because we just talked about that. We want to have a timer. So what we do instead is we reduce or remove these, and then we say on begin play. When this drop-off area is created, we will start a timer that will periodically tick, and for each tick it will check if there are any unaccounted for objects that it could take that are currently not being held by a player. The reason we're not doing this is because normally some people would be inclined to use tick. The tick event is something that's run every frame when you're running a game, and it's very easy to build in logic in tick because it's convenient, but it's not very good because it's very easy to swell it up with a lot of game logic that you feel you have to use it here because you need to check everything at the tick because it's easy and it's always there. But I would say the rule of thumb for when it comes to tick is never use tick. That way you only use it when you really have to, when you have no other options. So always try to find a different way of doing things than tick. So we'll remove tick and instead we'll drag off begin play and we will say timer, and then we have set timer by event. So what this is we're setting an internal clock on this. Once this object is created, we set an internal clock that has a repeatable timer here. You can choose to do it after a certain amount of time and just once, or you can click in looping, meaning that it will tick every now and then. So we talked about earlier that how we want to have it check maybe once per second, let's say. So we'll type in time 1. We will promote it to a variable just to be having a good behavior, and we will change the name from time to scanning time interval. So the amount of time that goes between each time we scan for an object. We want to have it looping, and then we want to have an event for it to call on. So we'll type in custom event, and then we'll type in the name scan for objects. We will hook it up with the red connector up here, and then we will print saying scanning. Compile, save. Let's put our drop-off area inside the world here. So this looks a little bit weird. There we go. The reason why it looked weird, or looks weird if you drop it down again, is this particular mesh or box that we made here is having trouble most likely with the floor, determining which one should be shown, the floor or the box. This is usually a problem that you can encounter when there's a talk about the depth. So the easy way to solve it is usually by clearly placing one a little bit above the other. So we can do that by removing the snapping, just placing it a little bit above. However, the artifacting seems to be coming from something far before we're actually reaching the ground, so I'm not entirely sure about that, but we'll place it a bit over for now. It'll be fine. We will come back to this later. Anyway, so now we have the drop-off area, and it should be scanning every half a second, and it should be telling us that it's scanning every half a second, every second actually, because it's going to print. So let's test that out. We press play, scanning, 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 scanning. Seems to be working fine. Okay. The first issue we have here is that this is so small, so we will scale it up. So we will choose the scale tool. We'll scale it along the green and the red, because we mainly want to have it in this dimension. Move it around a little bit. There we go. That should probably be okay as a scanning area or a drop-off area. Now, to the next part. We are almost at the point where we have the core done. We can pick up an object, we can drop down an object, but we can't place it in a drop-off area yet. So we go back to our drop-off area, and we say that in the scan event, when it happens, it wants to check its drop-off volume, check for overlapping actors. That's not the one we want, and we want to change the class to BP pickup. Then we want to loop. So what's happening here is then we get pinged that we want to scan for objects. We say, okay, everything in the volume, get all the actors that I can find that are of the type pickup. For each of them, loop through them and then do something with it. And then we can print finished scanning. So we have some debugging of what is happening. For each object that we find in here, we want to destroy it, meaning remove it from the world. So we'll do that. Destroy actor. So everything that is placed inside this volume, when it scans, get destroyed, and we can print a little message saying something so we know that it has happened. Destroyed actor. Compile and save. Let's see how this works out. Pick up our object, we walk to the area, we release it, and there it disappears. So that seems to work. That is all for part 1. Hope to see you in part 2. Keep on learning. Take care.